Good afternoon. I'm going to give you a few news about a lot of stuff about former PV market, but the former PV market was, in this country, was essentially driven by off-grid, while we are going today to on-grid market, like almost everybody. And there are some news, just who came this morning, and I had no time to change the presentation. Let's start from the legislative background, because there are still a lot of problems in Morocco to inject PV electricity in the grid. So what is the present situation? The law, we are working within the framework of the law 13/2002. This law has 2009, sorry. This law has liberalized the access to the grid for renewable electricity production, but has blocked implicitly the low voltage electricity. In last August, the government has written a law proposal, which number was 58/2015, and it brought some technical adjustment to the law, to the former law, and it opened finally the access to the low voltage network. All these things will be regulated by an agency which should be created this same autumn, National Agency for Electricity Regulation. All this information is new. It concerns this autumn. The other aspect, which is not legal but regulatory, is different. We are not at the level of the law here, but at the level of rules, how to do. For medium voltage, the core of the regulatory aspects are supposed to be fixed by the law 1448/2015. And more regulations to come by end of 2015. I'm proud to tell you that they came out this morning, exactly this morning. Proud and not proud at the same time. I must confess that these laws were, these regulations were written without any discussions with the private sector. I mean, there's a complete blackout at the ministry, and I'm afraid that part of this regulatory will have to be amended, because obviously not all the players were around the table when they were writing these rules. Anyway, we have now a regulation, and let's say theoretically, as soon as possible, some people will be able to inject electricity through the medium voltage grid. We'll see why later. I'm wondering essentially on low voltage and medium voltage. We'll have some numbers later explaining this. In low voltage now, when the law will be voted at the parliament very soon, next week probably, we will need a regulation. But for sure, Morocco will go for the net metering approach. In the net metering approach, we'll see what it is. The customer investor pays and installs the system. He injects in the electricity in the low voltage grid. He pays the electricity balance at the end of the month. He is not paid for not falling electricity surpluses, meaning that if he overproduces electricity, it's lost for him. It's lost for him, it's good for the community. For this reason, sizing the photovoltaic system is critical. Because obviously, if PV is competitive with low voltage electricity, which is the case today, as we will show later, the interest of the installation company and the interest of the investor is to make the installation as big as possible. But once it is too big, it's too late. because all the kilowatt hours injected and not taken back are lost at the end of the month. You know, meaning that, let's say it's quite simple. You can have two counters, one in and one out. You count the electricity you give, and you count the electricity you take. And you pay the difference if the difference is for you. But if the difference is for the distributor, you get nothing. So for this thing, we will see later that why some people here around are acting in a common project to sort out this problem of sizing. Let's talk about cost. The situation, well, this has to be modified somewhat. This is a very simplified grid with from the very high voltage, medium voltage, and low voltage. And you have here, let's say, generators from coal, gas, and whatever connected all over here, except still there is nothing here. And the voltage goes down from actually 400 kilovolts to 220 kilovolts, and the price of electricity climbs from 0.8 dirhams per kilowatt hour to 1.3. It's an average, of course, because here it changes according to your own consumption. It's important to know, because what happens at the bottom line? These prices go increasing, meaning that today, here, wind is competitive, while here, wind is not competitive because small windmills are expensive per kilowatt, obviously not. And at the reverse, still today, PV is, let's say, not completely competitive, even if we have heard some other numbers yesterday. But if you want to make it commercial, I mean to make profit on it, not only in terms of cost, but in terms of prices, it's still not really competitive here, because these are prices, okay? The costs are lower than those. And while here, PV is competitive. Let's go and see some numbers. These are some diagrams like you have seen yesterday, like the ones you have seen yesterday with the levelized cost of energy. This is based on 2 kilowatt installations, small installations, let's say for a house or a family house, and installed in 3 parts of the Morocco, in the southern part, central part, northern part, and the same for these 3. What's the difference here? Here we have installation self-financed, or in which we consider no interest. And in this case, we have considered 6.5 interest rate, annual interest rate, or let's say actualization or whatever. At the bottom line, what we see, that the price for electricity in this country, or the price for the cost of PV electricity without financing goes from, let's say, 65 cents to 80 cents, without financing, up to 120 and 130 if you have to pay 25 years interest at 6.5%. You see that the financing cost part is just huge. Obviously, this nobody will have an interest to go and take a bank loan on 25 years to do it. But as soon as we are speaking here about family investment, in fact, the actualization, the depreciation or the actualization rate is negative, because instead of keeping your money without doing anything with it, you lose, in fact, minus 2%, you lose 2% per year. Now, some technical aspects. This is how finally this net metering works, and what I'm wondering about. So during the night, the building needs electricity, meaning that the counter out. You have electricity? Sorry. Yeah, this lights it's on. How it works? So during the night, the building doesn't read the electricity, and the building takes electricity. During the day, if the building does not need electricity, you have only electricity going out from the house to the grid, and almost nothing going from the grid to the house. And in the case of combination, you have the two possibilities: injecting electricity in the grid and taking back electricity. Let me just tell you something about these two counters here. I wrote this in a newspaper. Some of you might have read this. We have something like 7 million electricity customers in Morocco. These 7 million, if we remove 1 million customers, more or less, who have a numeric counter, all the others have an analogic counter, you know, just numbers like these. It looks like all what you have at home. And we did the test. When you take electricity, the counter counts. And when you inject electricity, the counter goes back. And this is the case of almost 90% of the counters of Morocco. We have done the test with several counters, Moroccan counters, and somebody did a movie on the thing. It's amazing how you can see two counters, you know, in a single wall with two counters, and one counter going in one way and the other counting going in the other way. I'm wondering about this because this means that we can do this without authorizations, without law, with nothing. And when PV will become so cheap that it will be very competitive, Al-Qari'a will take care of that. And nobody will wait the laws, and we will have a lot of non-allowed installations. I'm not wondering about the fact it's legal or not legal. I'm wondering about the fact that the inverters can be bullshit and set a lot of harmonics in the grid and disturb all the neighbors at least. A quick overview about the Moroccan market. In the latest, let's say 3-5 years, there were 3 studies done separately. GIZ has done a kind of a potential technical markets. Their number are just huge. 20 gigawatts of solar PV possible for Morocco without putting it neither in the time frame. We have done another study in 2002, and in the base case we found that the low voltage market should be in a time frame of 10-15 years of around 1.8 gigawatts. This is almost the solar plan. And this can be done without public money. And another evaluation was done by another consultant in 2013, and they have done a lot of scenarios. If, and they reach numbers like between 0.75, let's say 750 megawatts and 4.5 gigawatts. Opening this market is obviously getting few percent of our electricity in 2030 from this source without 1 cent of public money. Let's come back now to the problem I highlighted at the beginning, the specific sizing problem. You got the point, remember? If in net metering I don't get extra money, it's not feed-in tariff. In feed-in tariff, your interest is to do the installation as big as possible, because the more kilowatt hours you sell, the more money you get. While in net metering, you don't get money. You exchange one potato for one potato. And if you take more potatoes than the ones you give, you have to pay the difference. But if you give more potatoes, you don't get paid for it. No. Oh, no. This is no. This is not the net metering made in Morocco. This is in the net metering approach. In the net metering approach, you are supposed to be a consumer, okay? And that's it. You are a consumer, meaning that you don't have to get money. You are not supposed to get paid for what you produce. You are a consumer, and you are supposed to consume, and not to sell. Otherwise, it's another problem then. I know net metering concept works this way. Even in the US, net metering exists in something like 10 states of the US, and it works this way. No, because when you get paid for the difference, then you have to say what is the feed-in tariff, and that is called differential feed-in tariff. Meaning that you get paid, you get a feed-in tariff for what you do not consume. That's not net metering. That differential feed-in tariff, it's different. Anyway. This is the kind of problem. Let's say, obviously, the sizing problem, let's say, this is 2 simulations we have done, and we have done the same with the six other tools. This is one of the tools. The blue curve is a simulation program, a simulation of how much, what is the photovoltaic DC yield, meaning how much kilowatt hours per day you can get per kilowatt installed. The 2 curves, the red one and the blue one, have been adjusted so that the yearly yield is exactly the same. And what we see here, we see that the 2 programs do not agree. Okay, and I can show you 5 others that do not agree with the blue one. The blue one is hourly based, and it calculates the IV curve each hour or half an hour, while all the others are based on daily averages calculations. And this is the more, the program I'm showing you here is the more famous. It's PVSys. It's the one which is more widely used because of its good price performance capacity. And you see that there is a difference here. And the differences can go up to 14% and go down to 6%, minus 6%. Meaning that if you size the system with the wrong tool, then you have to choose or to do an installation 15% smaller than what it should be, or to lose money here. Not to lose money, but to give money to the community. And so, what's the question now? In 2014, we decided, in fact, we discovered that all the tools, all the existing tools like SolarMed Atlas, like PVGIS, even, I'm sorry, but even if these people are fair with blue eyes, but the monthly data they bring are just bullshit. I assume what I say. because they are based on formulas which I teach at the second year at the university. Almost all the calculations are linear. For feed-in tariff, these data are just excellent because what you need is how much money you get at the end of the year. And you don't care about if it's less in January or more in December, less in June and more in March. You don't care with this. Then this data is excellent for do that because it's calibrated for 1 year. When you do net metering, you don't need a yearly calibration. You need a monthly calibration. And we are now a group of 20 higher institutions, among which you can see Professor Baghdadi here. He represents Rabat for us. Professor Bukhatam, which I've seen, who is here. He's in the university, at the faculty at the engineering school in Safi. And some 18 other people are here. And we have installations all around the country to do maps, just like the one you see here, and to calibrate, to do viable monthly yields good for net metering approach. This is just quickly around this program. We did something not bottom up, but top down. We have 20 installations in Morocco, and we hope that we'll put 3 others in the extreme south. All the 3 are based in silicon technology, monocrystalline, polycrystalline, and amorphous silicon. We inject, actually, even if it is forbidden, but we inject in the low voltage grid of the institution, but we consume almost all the electricity we inject, so that's not a problem. The electricity doesn't go out. And each of these installations, we have an acquisition system which will go to a computer based here in Marrakech. That's it. We have 1 private company with us, 25 professors, 3 PhDs, and up to now 39 master students. This is I would have loved to have a friend with me here to speak about this, because this is something is not my job, but we are developing our own measuring system just because we are too poor. We could have done the project with the 16 institutions and bought our own metrology. But we didn't have enough money. We kept the 20 people. We are well together, and we are developing our own metrology. What I'm saying now is just recent, okay? We received another pack this morning to do 20 times what you see here. Basically, just quickly, we have a meteorological station here, which is connected with an acquisition storage board, and this works for the silicon monocrystalline. This one works for the polycrystalline, and this one works for the amorphous silicon generator. We are taking at the same time 22, 24 data, if I remember, wind direction, temperature, tilted insulation, horizontal insulation, module temperature 1, 2, 3, voltage at input, output 1, 2, 3, and current input, output 1, 2, 3. This represents something like 22 or 23 data. Oh. Okay. I'm done. This is the kind of things, this is what I'm giving you here, apart from, is really hot. This is 1 week. We have been making a lot of simulations. See, What is the best model, for instance, for temperature? These are data from an installation in Essaouira, in which we have taken, you see, a lot of different models, and we have even put our own model. This is just simple. It's the module temperature against the ambient temperature, and we went comparing different models to see what is the best model if we have. Why do we care about models? Simply because we will have the data, okay? But we have to bring this data back to a standard year, from 2016 year to a standard year, okay, based on the 1 decade of data. And for this, we have to choose the best model. Another thing here, the same thing. This is for the electrical part, and we are using other data coming from another installation in Morocco, which has 1 minute step of data. And we still don't have enough data from our side, but for sure, we are trying to get the best options for us to be sure that what we will do is just as perfect as possible. And another good news yesterday afternoon, and hopefully I couldn't be with you here, but I discovered that the tools, the computer tools we are using, we finished 1 year in Marrakech, and we did the same simulation with computer, and we compared it with the measurements. I can give you this number, it's brand fresh. Marrakech, you can generate 167 kilowatt hours per peak watt per year, and the program gave us 169. Not bad. I'm sure that it's quite difficult without calibration to get such a precision, but we calibrate our program in anticipation. We just don't leave them do what they want, but we anticipate on what they want, what we want them to obtain. Well, this is just to finish. These are the maps which will be calibrated. Actually, this is the one for monocrystalline, and you have here the 12 maps. Why do we need precise maps? Simply because if we are not precise, at least at the 20 cities in which we are going to calibrate, what will happen when we go from a city a place between Marrakech and Safi, for instance, okay? We have to be as precise as possible in the calibration points, precise in terms of time, and precise in terms of space. And just to finish, these are the photographs of the 20 installations over the 20 cities, and I will ask just my two colleagues here to stand up and to thank you.